Yeah, hello everyone. So we will solve some problems here in this lecture, and in the next lecture we will move forward with the concepts. Okay, only a few concepts are left. So first let's solve the problems. So you can try the problem on your own, then you can see the solution. Okay, so initial voltage across the capacitor is given, that is minus 2 volt. The current value is 20 milliampere. You have to draw the Vs waveform. Vs waveform is the voltage across the current source that you need to draw. Okay, so let's make the circuit for t less than 0. I have always said always start from t less than 0. That means always start from t equals to minus infinity. So circuit for t less than 0. So what is happening? This is shorted and this is open circuited because this is being closed at t equals to 0 and this is being opened at t equals to 0. That means for t less than 0, this is shorted and this is open circuited. This current source, okay, this is Vs, this is the current source I, then there is this capacitor 1 microfarad, and there is this 100 ohm resistor, and these are open circuited, right? This is open circuited. So tell me, where will this current go? This current will just keep on flowing in this loop because this end is open circuited, this end is open circuited, right? So the current will not flow there. So basically this complete path is short circuited, so your Vs for t less than 0 is always 0, right? And it is holding minus 2 volt charge, so it is there. So we can't really say from where this charge came, but Vc 0 minus is minus 2 volt, but Vs is 0 volt for t less than 0 because the complete current source is short circuited. That means there is 0 voltage drop across it, and the current is flowing in this short circuit path because the current cannot flow in this path, because if the current goes in this path, that is short circuited, so it can't flow there. Okay, so the complete current is flowing in this short circuit part. So this is the circuit for t less than 0. Now for t greater than 0, circuit for t greater than 0. This is current source I. Here it is open circuited, so I am not drawing that. This is Vs. Then we have a capacitor of 1 microfarad with the initial voltage of minus 2 volt. Okay, and a resistor of 100 ohm. Resistor of 100 ohm. Okay, this current value is 200 milliampere, I guess, 20 milliampere. Current value is 20 milliampere. So the same current is flowing through this capacitor and same current is flowing through this resistor. So this 20 milliampere. So this 20 milliampere current will always flow through this resistor. So here there will be voltage drop of 2 volt always. 20 milliampere into 100. So VR is equals to 20 milli into 100. That means 2 volt. So this 2 volt is already there. So what do you think? What is Vs? Vs is voltage across the capacitor plus VR. What is the voltage across the capacitor? That is minus 2 plus 1 by C integration I dot dt plus what is the value of VR? That is 2 volt. This is Vc and this is VR. So simply your Vs becomes, I is constant, right? So your Vs becomes It by C, right? So how will the waveform look like? Waveform will look something like this. And this is all happening at t greater than 0, so ut, right? So this is your Vs waveform. That is It by C. Okay, the slope is I by C, and you can find the value of I by C as well. What is the value of I by C? 20 milli by 1 micro, so it is 20k. The slope is 20k, but no need. This is theta. The tan theta is I by C. Okay, got this point? Very easy question. Okay, let's move on to the next question. So this is a good question. You have to draw the VCT waveform. Okay, this waveform you need to draw, VCT waveform, and this is the condition given. There are switches S1 and S2. Okay, so S1 and S2 are mechanically operated. So for time being T2, 2n T2, 2n plus 1 T, switch S1 is at P1 and switch S2 is at P2. So that means this switch is connected here and this switch is connected here. Okay, and then you have to draw the VCT waveform. So I will just take the condition given for 2n T2, 2n plus 1 T. Switch S1 is at P1. At P1. Let n equals to 0. N can be anything. Let's take n equals to 0. N can take values n equals to 0, 1, 2, 3 and so on. Okay. So n can take any value. So let's assume n equals to 0. So for time 0 to t, for this much of time period, for 0 to time t, how will the circuit look like? This switch is at this point. So this 1 ampere current source will come in series with the capacitor, right? So basically we will have a resistance of 0.5 ohm, 1 milliampere current source, and we have a capacitor. Okay, let's just make it with the different color of pen. We have a capacitor. Okay, the value of capacitor is 1 farad. Okay, and the source is 1 ampere as well, not 1 milliampere. 1 farad. Okay, and this is VCT we are talking about. What is happening for switch S2? Switch S2 is at P2. That means this 1 ampere current is flowing in this direction. 1 ampere current is flowing here in 1 ohm, 1 ohm. It is not connected to VCT. So basically what is happening there, that is another 1 ampere current source is flowing in this 1 ohm resistance. Okay, but that's of no use actually. So basically there are two 1 ohm resistance. Okay, so what is happening? This 1 ampere current is flowing through the capacitor, and this one not 1 milliampere, this 1 ampere current is flowing through this resistor network. That's of no use actually, right? Because we need to draw the VCT waveform. So for 0 to 2t we can draw the VCT waveform, right? VCT is IT by C, right? Or I will just say 1 by C integration I dot dt, right? So it would be IT by C. What is the value of C? That is 1. Value of I is also 1. So VCT is simply T now. For 0 to T. Okay. So we are drawing the VCT waveform. VCT. For 0 to, it rises from 0 to capital T, right? At time capital T, the value of VCT would be T only. Because we can clearly see at T equals to T, the value will be T. So this is how it rises, right? So at time T, the value of capacitance value will also be T. This is voltage, this is second. Okay. this is in second, and this is in volt. Okay, so this is happening in the first cycle. Now in the second cycle, for this is given for 2n plus 1 t to 2n plus 2t plus 1 t to 2n plus 2t. Switch S2, switch S2, where is switch S2? Switch S2 is at Q2. Switch S2 is at Q2 and switch S1 is at Q1. Now this switch goes here. This switch goes here. So this 1 ampere current will flow into this, and that doesn't really matter because we are considered towards VCT. We need to make the waveform of VCT. So we will just make this circuit, right? No need to make this circuit because this 1 ampere current is flowing here. So no need of that. Only this much of circuit is the matter of concern, because the switch S2 is connected here now and this one is connected here. So this 1 ampere current is flowing in this direction. That's not a matter of fact, but this is the important part now. Okay, so we will just make this circuit. Switch S2, switch S2 is at Q2, right? Switch S2 is at Q2. Take n equals to 0. Take n equals to 0. So basically from T2, you can write like this, from T2 to T, or whatever it is, equal sign doesn't really matter here. From T2 to T, what will be the circuit? Let me put the charge. So this is going to be the condition, right? The capacitor, a resistance, and then a current source. Then this current source, right? The capacitance of 1 farad, right? Now this 1 farad is already having T volt across it, and the direction is this T voltage. T, just I am writing T. Okay, T. This is already having T voltage, and in which direction? Because this current source was charging in this direction, right? This current source was charging in this direction. So this was having T voltage already. Now this switch is connected here. So this is already having T voltage, right? So this is already having T voltage, and now 1 ampere current is flowing towards it. This is 1 ampere, this is 1 ohm. Now this 1 ampere current is flowing here. Now you need to write down the VCT value, right? So we will write down the VCT value, that is T voltage it is already having. Now the current is flowing out of it. The current is flowing out of the capacitor, so it will discharge the capacitor. So minus 1 by C integration I dot dt from T by 2 to some time T. Sorry, not T by 2, sorry, from T to some time T. From T to some time T. So it would be T minus, the value of C is 1, the value of current is 1. So it would be T minus dt T minus T, right? So it would be 2T minus T, right? So basically how will the waveform go? 2T minus T for time what? For T to 2T, right? From time T to 2T. So basically you can see first 1 ampere current charges the capacitor. Now 1 ampere current is discharging the capacitor. So the whatever the voltage it has developed, the same voltage it will lose, right? First this 1 ampere current source was charging this capacitor. Now this 1 ampere current source is discharging the capacitor. We didn't make this condition because this 1 ampere current will be flowing through this network. So that's not really matter. That's not really a matter of concern. Only the matter of concern is this 1 ampere current is discharging this capacitor. The same current was charging the capacitor, same current is discharging the capacitor. So whatever the voltage it has developed, the same voltage it will lose, right? So basically we will start from T by 2 now. Sorry, not T by 2. From T we will start. From here we will start. From T we are starting What will be the value at t? That would be t only. VCT we are talking about. So value at t is t only. What will be the value at 2t? At 2t we will have 0 voltage. So basically it is losing the voltage, right? From t to 2t, it is losing the voltage. So first it has developed, then it has lost. So basically your VC at 2t is 0 volt. And what was your VC at t? VC at t was t volts. Right? Now what will happen? Again this circuit will come into action. For take n equals to 1 now. Take n equals to 1 now. Take n equals to 1. So now what will happen? For if n equals to 1, then for 2t to 3t, for 2t to 3t, switch S1 will come in action. I am just writing switch S1 will come in action. That means it will charge the capacitor now. So basically, what is the resistance? 0.5. So basically, again the same thing will happen. Nothing is going to be changed. Right? This is 0.5 ohm resistor. That is not making any change. And now the capacitor will be charged. It is initially having 0 voltage. Now this capacitor will be charged. I will not write down the equation now. I will just draw the waveform. So how much charge it will develop? VCT. Initially it is 0. From 0 to, not from 0 to t. It is starting from 2t to some time t. 1 by c integration I dot dt. So it will be t minus 2t. So at 2t it is having 0 voltage, and then at 3t it will have t voltage. Time is from 2t to 3t. Right? So let's just assume this is time 2t. So from 0 to t it will go. From 0 to t it will go. And how much charge it has developed? T charge only. Because at 3t what you will have? Vc at 3t what you will have? 3t minus 2t, that is t only. T volts. Right? So from 0 to t volt it will develop. Right? Now what will happen? This t voltage is developed. Now for this is a simple problem actually, nothing difficult here. Just I am just solving it, so it is taking so much time. But if you just see the circuit, it won't be that much of difficulty for you, right? For T2 4T, switch S2 will come in action. Now switch S2 will come in action. There is this 1 ohm resistance that is of no use. Wait. First here we have the capacitor, or I will just copy this circuit. Right? This circuit I can copy. So again, it is already charged to 1 volt. Sorry, T volt. So what will be your VCT now? VCT would simply be, it is already charged to T volt. So T, and this 1 ampere current will discharge the capacitor now. So negative sign into I dot dt. From where to where? From 3t to some time t. Right? Some time t, small t I should have written. Some time t. Right? C value is 1, I value is 1. So it would be t minus 3t. So it would be 4t minus t. So what will be the value of Vc at 4t? That will be 0 volt. Vc at 4t will be 0 volt. So again, t voltage that was developed, that will go down to 0, and this cycle will go on. So now you can assume how will the final waveform look like. But for now, let me draw the waveform for 3t to 4t. from 3T to 4T. This was developed at T volt, and then from T to 0 it goes. So this cycle will keep on going, and this cycle goes on. So this is how the waveform looks like. VCT of T, right? So first it charges, then it discharges, then again charges, then again discharges, again charges, again discharges, right? And this cycle goes on, right? What is this time? This is T, this is 3T, this will be 5T, and all have the same peak. What happens? From 0 to T it charges and gain a voltage of T volt. Then from T to 2T it discharges and goes to 0. Then from T to 3T it charges and gain a voltage of T volt. And from 3T to 4T it discharges and goes to 0. From 4T to 5T it charges and gain a voltage of T volt. And from 5T to 6T it discharges and goes to 0 volt. So this cycle keeps on moving. Okay. So this is the waveform that we are generating at the output. Okay. At VCT. Have you understood the question? Very easy question. So in the exam, if this question comes and someone asks you to draw the waveform, you wouldn't be doing all this. You would know, okay, 1 ampere current will charge T. Okay. Now this same current will discharge like this. The waveform will go on like this. Within 10 seconds, you can answer the question. If you just read the question very quickly and just say, okay, charge, discharge, charge, discharge. That's it. Okay. Not much of difficulty would be there. Okay. Okay. So let's move on to the next question. This is also a very simple question. The switch is open for a long time until steady state is reached. So now the switch was open and steady state is reached. Now the switch S1 is closed at t equals to 0. You have to find the current at t equals to 0 plus. This value we need to find at t equals to 0 plus. So circuit for t less than 0. Circuit for t less than 0. So what was happening? This was 1 farad capacitor. 1 ohm resistance was there, and now the switch was open, right? The switch was open. So this 1 ohm and 1 ohm, oh, both will be in action because this is open circuited. So 1 ohm and 1 ohm both will be in action. So this 1 ohm will be in action. This 1 ohm will also be in action. So basically this is 1 ohm, this is 1 ohm, and here we have 3 ohm, right? And then we have current source of 8 ampere, right? 8 ampere. Now steady state will be reached, right? Steady state will be reached. In this time only steady state will be reached. So steady state will be reached in some time. This is actually circuit at t equals to minus infinity. Circuit at t equals to, what I will say, at t equals to minus infinity, at t equals to minus infinity, capacitor is shorted, capacitor shorted at t equals to 0 minus, that means I am talking about steady state. So at steady state, capacitor will be open circuited. Open circuited. So that means steady state will be reached. the switch, the circuit remains in this condition for a long time. I will write the circuit remains in this condition for a long time. In this condition for a long time. That means steady state is reached. That means what will be the VC value? This is simple network analysis problem. I want you to solve on your own. What will be the VC value? 4 volts, right? So VC 0 minus would be 4 volts. And why am I am interested in why I am interested in finding voltage only? In case of capacitor, whenever we talk about steady state, we will always find voltage, and in case of inductor, we will always find current. Why so? Because they have the property of taking, they have the property of not changing the voltage, right? They don't change the voltage instantaneously. So because of that property, we will always find the voltage across the capacitor. So we are finding the voltage across the capacitor, that is 4 volt. Why so? Because this will be open circuited. So 3 ohm, 3 ohm. So both of them will be in parallel. So this complete branch will take 4 ampere current, right? This branch will take 4 ampere current, and the same current will be flowing here. So 4 ampere into 1, 4 volt, right? So 4 volt will be there. VC 0 minus will be 4 volt. Now what will happen at circuit at t equals to 0 plus? So I can take next page. So circuit at t equals to 0 plus. What will happen? This 1 farad capacitor will be having 4 volt, right? VC 0 minus would be equals to VC 0 plus, that means 4 volt. Okay. And there is this 1 ohm in parallel. This is already having 4 volt. This is 1 ohm in parallel. And now tell me, what will be the resistance here? Because switch S2, S1 is closed now. So only 1 ohm will be in action, right? 1 ohm will be in action. So only 1 ohm is in action, right? And here 3 ohm and 8 ampere current source, right? Now tell me one thing, can I say things like this, that this 4 volt will come here, okay, the same 4 volt will come here, and the current will be 4 ampere here. Now this same current 4 ampere will be flowing from here, and now 8 ampere is going here, 4 ampere is going here, that means 4 ampere will be going here, and my V voltage will come out to be 12 volt. This voltage I need to find, no? Sorry, current I need to find. So forget about the voltage. So my answer would be 4 ampere. Is this correct? Is this analysis correct? 4 volt is coming here. So 4 ampere current, and this same 4 ampere current will be flowing from this resistor. If 4 ampere is going here, 8 ampere is coming from this side. So 4 ampere will be going this side. Is this analysis correct? No, this is not correct. Why so? Because even the capacitor will have some current. Okay. Although I see 0 minus, okay, this was 4 volt only. This was 4 volt only. Forget about this current. Although IC 0 minus was 0 ampere, right? Because it will be, capacitor will be open circuited. IC 0 minus would be 0 ampere only, because capacitor will be open circuited and steady state would have been reached. But it's not necessary that IC 0 plus would have been also the same. Why so? Because capacitor doesn't hold the current, it holds the voltage. Okay, so that you need to also remember. So if you are saying 4 ampere current is flowing here, that doesn't mean the same 4 ampere current will be flowing from here. This will also have some current, right? Got this point? Well and good. The capacitor will also have some current. Okay, so that current is not necessary to know for now. So we just need to find the value in this current. We need to find the value of I at 0 plus, right? So only at 0 plus we are considering. So this is 4 volt, right? And this is V. So V by 3 plus V minus 4 by 1 equals to 8. V by 3, yeah. So V plus 3V minus 12 equals to choice. 36, 4, V equals to 9. So V equals to 9 volt we are having. Okay. So what will be the value of current? V equals to 9 volt we are having. So let V equals to, this is only at t equals to 0. Okay, we are talking about t equals to 0 plus. Yeah, we are talking about d equals to 0. So this V value is only at t equals to 0 plus. Okay, 9 volt. So what will be I 0 plus? So I 0 plus would be 9 by 3, that means 3 ampere. Okay, what will be the value of I infinity? I at infinity, tell me, what will be the value of I at infinity? That would be 4 ampere, right? No, sorry, that will not also be 4 ampere. Again we have to find. Why so? Because we will apply this will be open circuited, so we will apply the nodal analysis like this. V by 2, because this and this will come in action. So V by 2 plus V by 3 equals to 8, right? So it would become 3V plus 2V equals to 48. So 5V equals to 48. So V equals to 48 by 5. And I at infinity would be 48 by 15. Are you getting my point? Are you getting my point or not? So this is not the matter of concern. This was only the answer. Okay, you got it or not? What I am saying, this is the circuit at t equals to 0 plus. So we solved the circuit at t equals to 0 plus only. By solving the circuit at t equals to 0 plus, we got this answer 3 ampere. One important concept I have told you here, that this 4 ampere current will not be the same here. This 4 ampere current will not be the same. Okay, why so? Because this capacitor will also drive some current. Okay, the capacitor will also drive some current. So basically, we are saying 4 ampere current is flowing here. Okay, and 3 ampere current is flowing here. That means 5 ampere current would be going here. Right? So if 5 ampere current is going here and 4 ampere current is going here, that means 1 ampere current is going here. Are you getting my point? So here also you can see IC 0 plus is 1 ampere and IC 0 minus was 0 ampere. So IC 0 plus and IC 0 minus is not equal, is not same. Are you getting my point? I 0 plus is 3 ampere. So 8 ampere current is coming from here. That means 5 ampere current is going here. Right? If 5 ampere current is going here, this 4 volt, this is driving 4 ampere current. So there we will have 1 ampere current. So IC 0 plus is 1 ampere. Okay. Now this 1 ampere current will charge this capacitor furthermore and we will get some more voltage. So are you getting my point? So this is the point I wanted to deliver here. Okay. This was the important point. Let's move on to the next question. You have to write down the voltage and current expression across the capacitor for t greater than 0. Okay, let's forget about t greater than 0. We will just write down the complete expression. Okay, we will just write down the complete expression. This is u of minus t. What does that mean? That voltage is applied, 1 volt is applied at 1 voltage is applied for t less than 0. Right? What does u of minus t mean? What is u of t mean and what is u of minus t mean? Although I have told this concept in the previous videos, but still 1 for t greater than 0 and 0 for t less than 0. Now what does u of minus t mean? It would be 1 for t less than 0 and 0 for t greater than 0. Okay. So, I didn't even leave the slot. So, circuit for t less than 0. This complete circuit will be there. I will just copy it. Just one different thing, that is this u of t will not be there. This will not be there. Okay, only u of minus t will be there. Basically, I will replace this circuit with a battery of 1 volt. Right? U of minus t has nothing to do with the magnitude. Okay, someone may write minus 1 volt. No, it's not that. It has to do with the time. For t less than 0 it is 1, for t greater than 0 it is 0. Okay, so this is the 1 volt. Now tell me what will be the Vc infinity value, Vc minus infinity value. This is the initial condition. Initial condition means, here initial condition mean t equals to minus infinity, right? Because from circuit will start from t equals to minus infinity and then it will rise, right? So what will be the Vc value at t equals to minus infinity? It will be shorted, so 0 volt. What will be the Ic value at t equals to minus infinity? Ic value at t equals to minus infinity. So this circuit will be shorted and we have to find the value. I guess it will be 0.5 by 2. It will be 1 by 4 ampere. How did I find it so quickly? What did I do? I just found the Thevenin equivalent here. I don't recommend this method if you are not very much comfortable with the network. Okay, but I will just tell you how did I find. I just found the Thevenin equivalent here. What will be the Thevenin equivalent? 0.5 volt battery, right? 2 and 2 will be divided and 1 ohm resistance. 2 and 2 will come in parallel, 1 ohm resistance. And then this 1 ohm resistance will come in series and this will be shorted. So what will be the current? 0.5 by 2. That would be 1 by 4 ampere. Okay, so that's how you can solve. Okay, but see, slowly when you study analog electronics, network analysis and everything you will study, you will solve a lot of question. After that, it will be start clicking to you. If I was in second year or if I was in third semester or fourth semester, it wouldn't, I would have also applied that nodal analysis, V minus 1 by 2 plus V by 2 plus V by 1. So from there, I would have got the value of I equals to 1 by 4 ampere. But since I have solved many questions, so it clicks on to me that when should I apply that Thevenin equivalent and try to get my answer quickly. So slowly it will try clicking and you should try applying this method in most of the questions so that you will be comfortable with it. Okay. So we are starting from 1 by 4 ampere. Now what will happen at steady state? At a steady state. At steady state. That means t equals to 0 minus. Okay. Steady state. The capacitor will be open circuited. So basically your IC value at, this should be small, IC. So IC value at t equals to 0 minus would be 0 ampere. And what will be the Vc value? Vc value at t equals to 0 minus would be 2 and 2, it will be divided in the same proportion. There will be no current in the 1 ohm resistor because this is open circuited, so no current will go there. So only potential divider will be there. So 2 and 2 will have equal voltage. So it will be 1 by 2 volt. Okay. So in case of VCT, we are going from 0 to 1 by 2 volt. So what will be the expression of VCT? VCT. From 0 to 1 by 2 volt we are going, no? 0 to 1 by 2 volt. So 1 by 2, 1 minus e to the power minus t upon 2 u of minus t. Why did I make u of minus t? Because it is happening for t less than 0, right? And what will be the expression of ICT? We are going from 1 by 4 ampere to 0 ampere. So it would be 1 by 4 e to the power minus t upon 2, but it is happening u of minus t. Did I write it correctly? What I will do, I will put t equals to infinity here, t equals to minus infinity here. What it will give me? It will give me infinite value. And this is not what I want. If I put t equals to minus infinity, this should be, this negative sign will not come. Look, in the exam, it is very, very rare that they will ask you for t less than 0. Okay. But just now I decoded one thing. If I put t equals to minus infinity here in this problem, if I put t equals to minus infinity, what will be my answer? I see a t equals to minus infinity. It would be 1 by 4 e to the power minus of infinity. So it would be 1 by 4 e to the power infinity. So that would give me infinity answer. But this is not our case, right? That's why I removed that negative sign. Now, if I am removing my negative sign, what will be my answer? 1 by 4 e to the power t minus infinity. So 0 ampere. So IC value at infinity was 0 ampere. IC value at t equals to minus infinity was not 0 ampere. It was not 0 ampere actually. Okay, this is also not a correct expression. So I need to think about it. Let me think it. Okay, so I actually never thought of it. Just now only I thought of it and I just came up this formula. So for minus infinity to t, minus infinity to 0 minus, okay, for time being minus infinity to 0 minus, this should be the formula, okay. Y of minus infinity plus y of 0 minus plus minus y of 0 minus infinity e to the power t upon tau u of minus t, okay. How did I come to that? I just tried to write down the equation, okay. I need IC value. What is happening with IC value? IC value is, first it was 1 by 4 and then it is going to 0. So how will I write it in exponential form? I would have to write 1 by 4 1 minus e to the power t upon 2. At t equals to infinity, it is giving me 1 by 4 value. At t equals to 0, it is giving me 0 value, right? From 1 by 4 to 0 we are going. So just I just thought of it and then I wrote the expression. And if I have the expression, I just derived this formula. So one thing you can do, you can remember this formula or you can try thinking of the values. So what you already know the value at t equals to minus infinity, you already know the value at t equals to 0 minus, and you also know the response will be exponential. Now you know all these things. So now you can make the formula or just write down the equation. You try writing out the equation. Let's just assume you first wrote down this equation. So you just got to know this is not working because at t equals to minus infinity you are getting 0 value, and this is what not you want. You want some values. So this is not fine. Then you can try doing this formula 1 minus e to the power t upon 2. Okay, or you just can remember this formula. It is the same, just infinity is replaced with minus infinity and 0 is replaced with 0 minus, and e to the power minus t upon 2 is replaced with t upon 2, and this ut is of course replaced with u of minus t. The same formula is there, just you need to take notice here, okay. This is important, okay. So this is happening for t less than 0. Now what is happening? Circuit for t greater than 0. Now tell me what will happen. Will there be anything different? I just want to know, will there be anything different? Just face the circuit. Now tell me one thing. This capacitor is already charged to what voltage? This capacitor is already charged to, this is VC. This capacitor is already charged to half voltage, right? If this is half, now here we have only 1 volt. Here we have 1 volt. Now tell me what will be the voltage here? Whatever the voltage we are having here, this is the steady state only. Like this 1 volt, how much voltage it will give this 1 farad finally? Because of this 1 volt, how much voltage we will have at 1 farad finally at steady state? It will be 1 by 2 volt only, right? Look, what I mean here is that VC 0 minus is 1 by 2 volt. Then same VC 0 plus will also be 1 by 2 volt, right? What will be VC infinity? 1 by 2 volt only. VC infinity will be 1 by 2 volt only because at infinite this will be open circuited. So 1 by 2 volt also will come. So here what do you see? VC 0 minus is equals to VC 0 VC infinity. That means steady state is already reached. It is already reached. Right? Do you get my point? So nothing more will happen in the circuit. So nothing more will happen. Nothing more will happen. So how will you write the final expression now? For VCT. For VCT, how will you write the final expression? This was the VCT, 1 by 2 e to the power t upon tau, u of minus t. 1 by 2 e to the power t upon tau, u of minus t. Right? That means at t equals to 0, you are having 1 by 2 voltage. So this 1 by 2 will remain forever. So this is for t less than 0 and this is for t greater than 0. Let me draw the waveform as well so that it will be more clear to you. So from minus infinity it starts and goes till 2 volt and then 1 by 2 volt and then just remain there, right? So this is 1 by 2 e to the power t upon tau, and this is 1 by 2. So this portion is for u of minus t and this portion is for u of t. So this is what I have written. Okay. Now coming to ICT. What about ICT? Initially it is 1 by 4 1 minus e to the power minus not minus e to the power t upon tau u of minus t plus 0 ut, right? Because the current at t equals to 0 is at t equals to 0 minus the current at t equals to 0 minus is 0 ampere only, right? So it will remain at 0 only, right? It will never rise up. Okay, so the current will always remain at 0. So I will not just write down this equation. So basically what is happening, it starts from 1 by 4 starts from 1 by 4 1 by 4 ampere and then goes down to 0 and remains at 0 only. Okay, so what was this expression? This expression is 1 by 4 1 minus e to the power minus t upon tau ut u of minus t. It is actually starting from t equals to minus infinity, but there is no other way to show it. That's why I am showing it like this, and this is 0 ampere. This is for u of minus t and this is for u of t. Okay, this was very interesting concept that we studied here. Also I studied for the first time as well. So if they ask you for waveform for t equals to for t less than 0, it will be a very interesting problem. In exams they haven't asked it yet. Okay, so if they ask the expression for t less than 0, it will be very interesting. Like many of the students may get it wrong in first chance. Okay, so I'm looking forward that IITs will ask question from this now for t less than 0. Okay, for t greater than 0 they ask and we already know the formula and we write down the equations, but for t less than 0 this becomes very interesting, right? So now let's solve this problem. The switch S1 is closed for a long time until steady state is reached. So switch S1 is closed for a long time until steady state is reached and is opened at t equals to 0. Find the expression of voltage V for t greater than 0. Okay, so what is happening? Steady state is already reached. Let's just call this value as Vc. So just tell me what will be the value of Vc0 minus. You guys should be able to tell this value now. Okay, take your time and tell the value Vc0 minus. It will be 8 volts. Why so? Because S1 is closed and steady state will be reached. So if S1 is closed, that means this will be short circuited, right? Vc0 minus will be 8 volt, and what will be the value of V of 0 minus? That would be 0 volt, right? Because this will be shorted, right? The resistance will be shorted, so only 4 ohm will be in action and steady state will be reached, so capacitor will be open circuited. So this 2 ampere current will be flowing through the resistor. If the 2 ampere current is flowing through the resistor, the voltage drop this resistor is having, the same voltage drop will be across the capacitor. So Vc0 minus will be 8 volt and V0 minus will be 0 volt. Now for t greater than 0, for t greater than 0, for t greater than 0, here we have 2 ampere current source. This is 2 ampere current source. This is 1 by 4 farad. This is already charged to 8 volt and it will also remain there. Why so? Because capacitor has the property of maintaining its voltage. Now this switch will be open, so it will be shorted. Sorry, it will be open circuited, and this is 4 ohm, and this is V. So, and this we were calling VC. So VC0 minus will be equals to VC0 plus. That would be 8 volt. But V0 minus will not be equals to V0 plus, right? Because this voltage is not across the capacitor. This voltage is across the resistor, and voltage across the resistor may change instantaneously, right? Only capacitor will hold its voltage. Only the capacitor voltage will not change instantaneously. Resistor voltage will change instantaneously. So you can't say your V0 plus would be 0 volt. Okay, you can't really say this. Okay, so now you need to find V0 plus. So let's find V0 plus. How will you find V0 plus? Basically, what will be V0 plus? V0 plus will be 4 volt. How? This 8 volt, this is charged to 8 volt. Now this 8 volt, this 8 volt, this is 8 volt here. This 8 volt will be divided into 4 and 4, right? This 8 volt will be divided between 4 and 4 ohm resistance. So basically V0 plus will be 4 volt, right? 8 volt will be divided between these two. Okay, and what will be the value of V infinity? What will be the value of V infinity? That would be capacitor will be open circuited, right? At steady state, capacitor will be open circuited. So this complete 2 ampere will be current this complete 2 ampere current will be flowing through the resistor. So V infinity would be 4 into 2. That means 8 volt. What about VC infinity? VC infinity would be 8 into 2. That means 16 volt, right? VC infinity would be 16 volt because the voltage across 4 ohm and 4 ohm will be the voltage across the capacitor, right? 4 plus 4, 8, 8 into 2, 16. So 16 volt and 4 volt. So basically you are rising from 4 to 16, 4 to 8 volt. So what will be the expression of VT? From 4 to 8 volt. So 8 minus 4 e to the power 8 minus 4 e to the power minus t upon 2 u of t. This will be the expression of ut. Sorry, Vt. Okay. And what will be the time constant? Time constant will be for this circuit. So time constant will be 4 and 4 will come in series, and this is capacitor 1 by 4. So time constant is 1 by 4 into 8. That means 2 seconds. Right? This 4 and 4 will make 8. 8 into 1 by 4. That means 2 seconds. Time constant is 2 seconds. Okay. Time constant is 2 seconds. And this is the formula of Vt, and we can write the formula for Vct as well. So Vct is rising from 8 to 16 volt, right? From 8 to 16 volt. So 16 minus 8 e to the power minus t upon 2 ut with same time constant, right? Time constant is 2 seconds. Okay, got it? Let's move on to the next question. Okay, the questions are over now. Now in the next video, we will see some concept like the slope at t equals to 0 plus in RC circuit. Like this circuit is given, they can ask you what is the slope of VR at t equals to 0 plus, what is the slope of VC at t equals to 0 plus, what is the slope of IC at t equals to 0 plus. So there is the one method you can solve, that's by writing the equation and then differentiate the equation and then put t equals to 0. But there will be one more method that I will tell in the next lecture. Okay, thank you.